Hi, everybody. I'm Noelle Silver. I am so excited. Jimmy and I met via the LinkedIn. So we had an opportunity to kind of talk, but I do work at Red Hat, but my AI journey actually started about 7 years ago. And I took a couple very big dramatic turns. So I'll talk to you a little bit about that. I'll also encourage you kind of as we're going through this, if you have any questions, there's a Q&A. I think you guys can chat with everyone. So you're welcome to throw in something there as well. But happy to, usually in a meetup, I especially in a in-person meetup, I tend to be very interactive. So if you guys see anything, or if you all see anything that you have questions on, I would love to hear from you, or if you have comments or examples of how you've done this before. I will tell you though that I'll start off, first I always like to start my sessions with my why. These are my little humans that I have the graciousness of being able to raise. And my oldest son, Max, he's there in the pool. We do live in Florida, and I'm not sorry. I'm very happy to live here and be warm most of the time. But my son, Max, was born with a condition known as Down syndrome. It's a chromosomal abnormality. But when he was born, they kind of said, the world's not really meant for him. You probably want to put him up for adoption or put him in an institution. And as a technologist, which I have been my entire life, that is not the road I took. I decided instead to start working at some of the best and largest companies focused on not just technology, but really technology built to increase the world's accessibility to brands, to music, to the world. And so he was a big motivator to the companies I ended up working for. You can find me on LinkedIn. So that'd be awesome. If you all want to connect with me on LinkedIn, you can find out all the companies I've worked for and the really unique opportunities I've had to advise some of the largest companies, not just technical, but in retail, healthcare, banking, and finance. I've been involved in some really interesting conversations in some of the some rooms I never thought I would be in. But another person who motivates me is my dad. He's a Marine. He's a really nice guy down there in the lower right, and but he was hit by a vehicle as a pedestrian a few years ago, actually in 2014. And I was an early member of the Amazon Alexa team. I was employee 10 on that platform, and not Amazon Alexa in the sense of like what we might know it as, right? A product that you use in your kitchen, but I was in charge of building and launching language models, creating new models from scratch, and ultimately operationalizing them, which you might be surprised or maybe not to know that we had no code pipeline, no launch, no consistent launch of any of our models for almost 2 years. And it was pretty unbearable. I remember taking a picture and posting to Twitter where it said like 0 of 419 automated builds failed, or passed, right? It was like 0 of over 400 builds that were attempted in an automated fashion. None of them worked. And it was like, it was one of those things where we all looked around and realized but the people around me, the data scientists that I worked with, the machine learning engineers, the linguists, like none of them were experts in building a software pipeline that would get their models into the world. And so it's something I now focus on quite a bit. The last few years have been very kind to me. I've got lots of different awards for my work in this space. I have spoken to and been on stage with the world's, finest. I just recently interviewed Greg Brockman, who's the CTO at OpenAI. I am a GPT-3 user. I also am a GitHub Copilot user. I'm a big fan of, again, increasing and democratizing technology to make more people or bring more people closer to solving some of the world's hardest problems. Because honestly, I do believe that it's the people who will solve it, not necessarily. I mean, the tech's been out for a while. We now need people with good ideas to get some practice. So I just thought I'd share with you a couple of things. Yes, That is a Ninja cat, a 3D printed Ninja cat. It is one of my prized possessions, one of the best awards I got. But I am a Microsoft MVP in artificial intelligence. And I really do speak about what I'm about to share with you globally. However, the thing I'm about to show you is brand new, which is why I was excited to have an opportunity. I'm glad we ended up launching, because sometimes these things don't happen in the order in which you want it to. But we did just launch. I should show you guys my face, I think. We did just launch our this environment that I'm about to show you. So I'll say hi. I don't know if you guys can see me, but we did just launch this tool set that I'm about to show you like Monday, right? So this is like hot off the presses. It's pretty cool. And if I can do nothing else but plant some seeds on some things that you can use and tools that you could go dive into, I learn by doing. I built over 100 apps for Amazon Alexa. I have over 1 million unique users of those applications. I learn by building, and this is no different. I ended up building a pipeline at Amazon from scratch. Nobody had ever done it before for Alexa. It was not, even though AWS was a neighbor, we were not friends organizationally. And then I went to Microsoft and actually worked there for a couple of years and basically helped build 17 research projects, which were models, into what today is known as cognitive services. So I have really seen what it takes to take models that are just your idea, just something that you're playing around with, a research project you're testing, and a hypothesis you're testing, all the way to making it into a production ready at scale service that can be used by millions of people at a time. And I've done it now like 5 or 6 times intentionally, meaning I was part of it. And I've been, of course, at the surface level, I've been associated with hundreds of these types of scaled solutions. And now I realize lots of companies today are investing in artificial intelligence, right? Lots of companies today are investing because we did a study actually during my time at Microsoft. We went and we talked to 348 companies in the Fortune 100, right? They were pretty big organizations, and said, where are you investing in data science today? And all of these companies were building data science teams. That's not new, right? Organizations have had research and development innovation arms for quite some time. But this, I think, is pretty cool. These were the boxes that the Post-its, if you will, they came back and said, this is where we are working. And I then, of course, in my role, my job was to then bucket those industry-wise, right? So I have a few of these models that I focused on for retail, a few that I focused on for supply chain and manufacturing, a few for financial services, a few that were cross-industry, things like customer intelligence, things like predictive maintenance and optimization, like resource optimization is something every company needs. Intelligent search capability is something every company needs. So there were certain cross-functional ones. But I thought I always like showing this to us as data scientists, as those building these models, for a couple reasons. One, it's good for you to know what our customers are asking us for. These are the problems they want to solve. But two, it's also important to know that not every single company is going to build these models from scratch. As a matter of fact, more and more companies are starting to not invest in building these models from scratch, but instead leverage existing models. So having done work in data science at Amazon, at Microsoft, I have been a heavy collaborator at Google Cloud Platform. I now work at Red Hat, which is part of IBM. So I literally am like the definition of hybrid cloud, right? And I actually believe that as a developer and a data scientist, I'm a bit of a unicorn because I build apps and I create models for my apps, which is not normally in the same brain. But when that happens, right, when you put these worlds together, many companies have a gap between those that are building the models and those that are going to consume them inside their own company, let alone exposing it to the world. So I have had a unique opportunity to work on this in some of the largest tech companies in the world. And so I want to share with you a tool set that I was part of helping to create and bring to developers, and hopefully you'll find something that you think is interesting and unique. You'll actually see that I'm going to actually use a bunch of the things that Jimmy, you laid up perfectly around GitHub and leveraging Jupyter notebooks. There's so many tools that we consistently use. But one of the bottlenecks, one of the challenges we have, at least in the teams that I've been part of and that I've led, is that we all individually do everything a little bit differently. And at scale, those tiny differences turn into big roadblocks, big bottlenecks. And we don't really know it until that day when it's exposed through a scaling motion, like, Christmas. Or I was the vice president of engineering at NPR right as the pandemic was starting. And our volume of requests overnight doubled, like overnight. And then it was an election year. So it doubled and kept growing. And everyone in our world, meaning I owned all the technical resources, right? So all of the engineers, they immediately became DevOps people, right? Everyone who had a roadmap halted their roadmap and became the people that just made sure our web servers didn't go down. And if I had it to do over, I probably would have looked at how can I create site reliability, right? How do I do that in a way that's not going to completely decimate my team on the best day of our lives, which is when all of our our traffic doubles and requests for our services double. I don't want my app devs in the prime time I need them to build new stuff to now be focused on just keeping the lights on and bailing water out of our boat in hopes that we can keep ourselves afloat. So I'll talk to you a little bit about some of the tools that I've used in these experiences that have worked. Some of them are open source. I am from Red Hat. We are a enterprise software company, which means we sell software for a living, but it's all built on open source. And part of the ecosystem that I love, I actually started my career at IBM and then went to Red Hat back in like 2008 timeframe. And at that time, I went to Red Hat because I wanted to move away from proprietary lock-in into this world of let's build software. We, of course, sell that software, but we contribute everything we learn from real enterprise scaling customers. We contribute that back to the world of open source and let the open source community evolve even more quickly. And that is something you'll see echoed throughout some of the things I'll say here as well. And like I said, if anything I say kind of jumps up at you and you have a question about it or want to know more or have any comments whatsoever, feel free to jump in. Really quickly, I'm going to take you through kind of what AI and ML, how that looks like in Red Hat, the two major problems I have seen as a leader of data science teams, as well as a data scientist myself, and then how are this platform and a Kubernetes, right, application, cloud native app dev platform can actually help you deploy models to the hands of your developers in record time. I love it. I will tell you more about it when we get there. And all of this, as I mentioned, is based on open source. So though I'm going to talk to you and show you a productized version of an open source project, it just came out. It's in, we call it like field, I can't even remember, field development, field release. Anyway, it's in, it's basically in kind of a beta trial for customers, but it's based on open source, which you could also use today. Just go to the GitHub repo. I just encourage you that if you're going to get excited about this, jump into the community, start testing it out, but then also provide feedback, right? Contribute back to these projects because it's how we make, I always say the rising tide, it lifts all boats, not just the yachts, right? The yachts being the FANG companies, the IBMs, the Netflixes, the Googles, the Apples, the Amazons, right? But open source lets the rising tide of technology lift everybody. And that's what I love about it. All right, so let's take a look. First, of course, I do want to level set. I am speaking kind of from the data scientist perspective, right? My life as a data scientist at Red Hat and the struggles that I have, my life as a data scientist and leading data science teams at Amazon and Microsoft, and the trouble I had, right? The good news is I spent most of my time building models, which was awesome and fun, but it ended up, in order for me to scale, in order for me to get my model into the world, it had very little to do with the code that I wrote. It had a lot to do with all the other stuff, the minutia, as I call it, right? All the other things had to do with like the environment it was going to run in on AWS or on Azure. It had to do with resource management, infrastructure, monitoring, like none of the things that came in my little Python environment that I cared for and loved so much. It also, as a data scientist, I often was not, as a matter of fact, I was never the team that collected the data, right? So in natural language, I wasn't the team that was going out collecting and annotating the audio information I was using to create the natural language model, the NLU. I already, like that data was already curated and annotated by the time my work began. And so again, there's lots of these other pieces in like basically in the machine learning lifecycle that I didn't really participate in. However, of course, I'm a critical component in it. So this just kind of gives you a lay of the land, certainly at an enterprise level, right? Where we're expecting, I today talk to many CEOs, CIOs, CISOs, C-suite executives, senior leadership at very large companies, and I'm getting them to buy into the idea that data science isn't just an experiment. It's still an experiment, but it's not just an experiment. You can actually build data science and operationalize it into your applications and have your apps deliver that value right to your customer. Like it happens. It's happening right now. So I encourage our executives in the world's companies to start thinking about this and the impact that this decision has. But then we have, of course, our data engineering teams, right? Which we are constantly looking at people to join the ranks of this, this industry. But data engineers are usually the ones that gather and prep the data, that do the annotation, that make it ready for someone like me to actually build a model. And maybe I'm building that model from scratch, or maybe I am taking an existing model from any of the available partners and cloud providers that have them and augmenting what's called customizing, right? That model for my use based on the data that I have. But still, that data work is a very important part of the life cycle, but not necessarily one that I, as a data scientist, have really worked too much on. Then I need to deploy my model. I typically deploy my model right inside my own environment. It's funny, Jimmy, you said something to the effect of like that constant quote we always say, like, it works on my machine. I don't know what's wrong. I'm not sure why it doesn't work in, staging or production. So similarly, as a data scientist, I rarely deploy to like an integration test environment. Like that concept or that life cycle is not something that I'm familiar with or something that I usually do. I do now. But when I was originally just primarily focused on the work of data science, building a code pipeline and participating in it was not my primary goal. And then, of course, in order for our data science work to show up in the world, it typically is going to be consumed by an application and made available to an app developer somehow. That's kind of the two areas that I'm going to talk about here is, in the life cycle, where are the biggest bottlenecks? Where's the biggest amount of friction? I think we just talked about Kubeflow automating a lot of these activities and providing a consistent platform for viewing them. But there are certain points of friction, at least that I have experienced, that I wanted some help with or resolved. And you can see in this, like we've actually, in machine learning, or at least in the machine learning teams that I've been on, right? Like figuring out what problem we're going to solve, identifying the data, collecting the data, annotating that data, making sure that it's ready, building the model, feature engineering, training the model, right? Validating the model, deploying the model, monitoring the model, using the data from the monitoring to improve the model and going through the cycle again. Like this was like my software development lifecycle, right? SDLC, but for data science. And as an engineer, I grew up in enterprise Java. As an engineer, I was like, wait a second, this is pretty, like it models what we do in software engineering. It's why I became so successful at Amazon Alexa, because I happened to be a like classically trained software engineer in a room of data scientists. And I was like, it's one of those things like when you go into this room and you say, we could model a DevOps practice. And you had mentioned this as well earlier, like MLOps, it's new, but it's not. Like a lot of the things we've learned in building infrastructure pipelines is completely transferable. The terms change a little, but it's very transferable. And as soon as I made that connection at Alexa, we built a Tiger team, we created a pipeline, and we started like literally exponentially growing the amount of features we were releasing on a weekly basis, sometimes on a daily basis. It's pretty incredible what you can do. So DevOps, you had mentioned this also, Jimmy, so I'll quickly go through this. There's a bunch of stuff in DevOps, right? DevOps is typically attributed to application development, software development life cycles, right? Where DevOps is how does an how does an IT operations person be friends with an application developer? For those of you not familiar with this world, it's like a high school dance. IT ops on one side, devs on the other, and they don't really want to talk to each other, right? Like it's like everyone's like, I'll just do my thing over here. I'll just hang out with my people, right? And sometimes it's even a bit, like contentious, right? Where developers are like, I asked IT ops for that. They wouldn't give it to me. Or I asked IT ops, it took them 3 weeks. Or I asked them for this. They said they had to build a pattern and deliver it back to me, right? Like there's this contention or this tension that is existing between these teams. Well, fast forward to now, we are starting to see, and what we want to do is avoid this. We're starting to see that same, kind of tension start building as new data science orgs are popping up in companies, as data engineering orgs, business analysts and business intelligence orgs are popping up. Like, how do they play? DevOps was created to simplify and reduce the friction of that relationship, right? Like, what if I, as a DevOps engineer, can curate an environment that makes it easy for a dev never to talk to me, never to have to submit a ticket to me? They could self-provision. I control what gets provisioned. So I, as the IT ops, get an environment that's consistent, that I can automate builds. I can ensure that if there's a problem, I protect production, I protect staging, right? But at the same time, I give the flexibility and freedom to the dev team to do what they want to do and do what they do best. Well, we are now in that same environment for data science. How do we do that same thing for data science, right? How do we create an environment that allows data scientists to provision their dev environments, right? Provision Jupyter Lab at ease, right? With the restrictions and guardrails that IT ops might want to put around it. How do we create an environment for them to test and deploy models? How do we create an environment for them to push their models into production or into the hands of a dev and get, and monitor the behavior and, potential drift of those models and be able to augment their models, train their models, and push out a new version? So I'll talk to you a little bit about that. And I'm going to try to, I want to give you guys a chance to ask some questions. I don't know how we open it up at the end, but I'll demo it to you as well. But I also have an entire YouTube, experience, a series of videos that goes through this step by step as well. So the first thing in data science, right? These are the two areas of, in my mind, of pain. One is, as a data scientist, how do I provision my environment easily, consistently, without me having to worry about what packages are running, Python version, NumPy, Panda, like all the things, Anaconda, like how do I make sure all of that, like I can get up and running fast? And then on the other end, how do I get what I've built into the hands of a dev as soon as possible? So those are the two kind of pain points. It's iterative. We go through this process, right? It's an iterative process. It's small iterations. But I still run into friction every time I try to build a new project or deploy at the end of a project, at the end of an iteration, deploy it so I can get some feedback on how it's going to be used. So in the middle of this life cycle, we often are seeing Jupyter notebooks. I'm a AI MVP at Microsoft, so you could probably guess that I also have leveraged Databricks. But the concept is the same, right? We've got some notebook environment, cloud-based infrastructure that's provisioned to run our data science work, and feature engineering, model development, training, tuning, validation all happens within this environment. So wouldn't it be great if we could do that consistently? Today, what happens, or I should say, in the teams I've been in, maybe you guys have a different world, but in the teams I've been in, I could go to 10 different data scientists' desks and they will all have done it a little bit differently. They'll be loading different versions of packages. They'll be using a different software. They'll either be doing it on their own machine or virtualized off of a machine in our on-prem data center, or leveraging a machine in the cloud. No one's doing it exactly the same way. And there's a danger to that, especially as an operations professional, right? Where how am I going to ever make sure that the outcome of those models is consistent if everyone's building it in a slightly different environment? And this is just true because most of the time data scientists don't even care that much, right? They're not thinking, ooh, I better make sure that this is going to be consistent with the production environment I'm going to. Very rarely is that within the scope of a data scientist's work. So we want to automate that. And at Red Hat, we realize these two dilemmas are pretty significant. Being able to self-serve, and here's the key, repeatable, shareable environments for building, repeatable and shareable environments, like the experiments themselves need to be repeatable. A lot of reasons behind that. If you're not familiar, I know I showed you one of my awards. I'm very passionate about responsible use of artificial intelligence and responsible development of data science workloads. And part of that responsibility is building repeatable experiments, building explainable experiments, building interpretable models. And so creating this environment that allows us to repeat it is just one step towards that responsible use. Getting into production, that's a whole nother thing, right? How do I make sure that these resources that these models need are available in production? How do I make sure it can scale, right? How do I make sure that I've provisioned enough or the right infrastructure to support the models at scale in production while they're being used? So I'm going to talk through both of them relatively quickly, but like I said, I want to point you to this just to plant the seed of what's possible so you can go and take a look at it. Containers is the way to go. I think you, of course, beautifully talked about it earlier, Jimmy, that when we build anything, we want to build it in a way that can be reusable, that can be moved around, that's not fragile, right? It doesn't break because we change its environment. And that's the world most data science lives in today. If I build a model, if I pick that model up and drop it somewhere, chances are the environment I'm dropping it into won't have the right anything. It won't have the right packages. It won't have the right, even the right ecosystem in order for it to do what it needs to do. So building containers allows you, when you build your model, to surround it with all the things you need. NumPy, pandas, mat, R, any library that you need for it to do its work. And then you put it in a container, Kubernetes, and you place it in an environment where you can manage and scale it. And I'll show you what that looks like. So really, we're creating an environment like Jupyter Notebook as a service, right? We want, as a ops professional and as a data scientist, I don't want to care about these things. I want to push a button and have an environment that is built to suit the work that I am doing. I want to work less on setting up. I mean, I don't know if you know this, but 35% of a data scientist's job is typically spent on curating the right environment and curating, right, the right resources. It's what a waste. So the other thing though, and this is my favorite part. So if you weren't like going to write anything down, now is the one thing I would say, this is magic. When you build a model and you prove that it works, right, in your own little Jupyter Lab environment, what you want to be able to do is quickly create an API for accessing it. This is open source. It's available in GitHub. You can go get it today. You can take a model, right? We usually create a prediction Python script, right, for representing the prediction. You could create that Python script and deploy it in an application as an API. Now, anyone who wants to leverage your model will hit that API. But guess what? The API, as maybe you know, right, that API is basically a pointer to the model. So if I update the model, if I improve the model, guess what? Everyone who's pointing to that model gets. They get the latest and greatest version of that model. This is how we operationalize, right? We operationalize data science by creating an interface that developers can use throughout their application, and it won't break if they move their application from running on a MERN stack to running in AWS to running in Azure or on GCP, right? It won't matter because it's a fully, like it's a containerized app, but it's accessing a URL that's hosted, right, in a cloud-based environment, this environment that I'm talking to you about. So creating a service endpoint for your models is the way that you can operationalize it. Best companies in the world have done this, right? Microsoft has cognitive services, 30-something models that are now accessible via an API, meaning there's a bunch of work that goes into building the model, training the model, tuning the model, validating the model, checking the model, and improving it over time. But you as a machine learning engineer or a developer, you no longer have to worry about that. You could just consume the API. So if you're a data scientist, we want to borrow that model, right? We want to be able to build our models as microservices and just tell devs, oh yeah, if you need a object detection model to detect, maybe you're, I don't know, at PetSmart, a store in the US around, that sells pet supplies, and you want to monitor foot traffic and you want to tell if someone's human or a canine, right? Maybe you create an object detection model that tells you that information so you can do a better job of understanding how many actual canines come into your door, or felines for that matter, right? You, instead of saying, well, it just becomes so easy as a data scientist. I create an API for my object detection model. I hand it to my developer, and in their mobile app or in their edge device that's doing all the monitoring, right? They just add a few lines of code, right, that accept the incoming video feed or accept static images that are taken once a second and pass them through to your model to get its outcome, right? To get its prediction. And then use, of course, as software engineers, use that prediction to do something, right? Identify create a Tableau chart if we wanted to do that. But microservices is the key. The last thing I want to talk to you about is how monitoring and performance. And I think I've 4 minutes. So monitoring and performance is so big. And I'm going to go ahead and, I'm going to take you into just a view of this world as I finish this. But the nice thing about a platform like this OpenShift data science, is that it allows you to integrate Jupyter Hub, but it also allows you to create metrics for your models and expose them in a SQL-like format to the monitoring tool within the OpenShift platform. It is a dream for your IT ops team to be able to get user or developer, data scientists define metrics for models. So this shouldn't look too new to you, right? We've got all these really cool things that we've seen before. This is actually an example that I'll share with you. If you hit me up on LinkedIn, I'll send you the tutorial you can walk through. I helped to build it. It's pretty simple, right? It's an object detection model that detects a bunch of stuff. It's based on a pre-built, predefined model, but it goes through and it uses Flask. I was a big developer on Flask in Alexa. And so I use Flask for this. But the most important thing is that inside of, I can't see it because of this little button. There it is. But your developers, right? When I build this inside of OpenShift, I can create an API. My developers, let me just move this over really quick, right? Will now get, notice here, I'm in the administrator view of OpenShift. I'm going to get a set of routes, and these routes are routing to my object detection app. So that's going to be the link inside of the prediction model that says, or inside of the application that the developer is building that says, give me your images of your pets or of whatever you want, and I'll tell you if there's animals in it, or I'll tell you if there's humans in it. So I'm going to show you now the developer version, and this is how we'll end it. This is a view of OpenShift, specifically running a data science project, right? Python plus Node.js. What a beautiful combination. But here's the cool thing. You can see here, I can go right to the source code. That'll open up the GitHub repo this content is sitting in. It also shows me the latest build, success or failure. And then I can here open up the app itself. And when I open up this app itself, like it's like a very simple application that I built. Hi. And I wanted to show you, like right now, like this is going against the model that I created and the route that I defined within OpenShift. And so I could just, I should take a picture with my little dog. Hi, right? it instantly leverages that computer vision. There might be a dog. Oh, look, 42% sure it's a dog and a toy, I think. Right? So this gives us the ability to build data science models, but most importantly, deliver that value in an application and be able to see both the admin side of the house. See both the admin side of the house and the developer side in the same window. Roadblocks removed. It's pretty cool. So this is just meant to plant some seeds. I hope you'll reach out to me. I would love to show you more. Thank you so much, Jimmy, for having me. It was a pleasure. And yeah, I know it was a little bit rushed, but I think it was fun.